Every fire alarm system type explained. Conventional system. Conventional systems groups the initiating devices by specific zones to show location of the device, and can specify the type of devices. Zone types can include front lobby smoke detectors, floor 2 pool stations, and all water flow tamper switches. Compared to other systems, conventional systems are very cheap and simple to install. It is easy to replace devices. No need to reprogram the system if you need to replace a smoke detector, for example. On the other hand, there is no pinpoint locations for devices, unlike addressable systems. Conventional systems usually lack more advanced features, such as monitoring the exact smoke values of a specific detector. Multiplex system. Multiplex systems use transponders that are connected to a central multiplex panel using data cables. Each transponder requires external power, and inside each transponder cabinet, there are conventional zone cards, signal cards, and control cards. This includes systems such as the older Simplex 2100 and 2120, and includes modern systems such as the Simplex 4100 ES with miniplex transponders. Compared to other systems, multiplex systems are a lot more flexible than conventional systems. Transponders can act as a standalone fire alarm panel if data connection is lost with the central panel, and transponder cards act a lot like conventional systems. It's very easy to add or replace devices connected to those cards. On the downside, they are a lot more expensive than a standard conventional system, and they still lack the advantages of pinpoint device location of an addressable system, and they require a technician if new transponders are needed or if a card needs to be replaced. Addressable system. Addressable systems are a type of multiplex fire alarm system. They use a single pair of wires to give power and data to each device, such as pool station and smoke detectors. Each of these devices have a small transponder inside of them, either using a dial or a dip switch to indicate the device it is. Honeywell uses dials to address these devices. The detectors and monitor points can share addresses. Simplex uses dip switches. Detectors and modules cannot share addresses. EST uses the length of the wire and a built-in randomized address within each detector head to determine device number. However, you can use an external programmer to change the address if so desired. Siemens? I'm gonna be real, I don't even know. And Mercom. Who uses Mercom? Compared to other systems, addressable systems can show you the pinpoint location of most devices on the system. The programming is much more advanced, and detectors usually give you live sensor data. On the other end, they have been historically much more expensive than conventional systems. They usually require programming if switching a device, especially detectors, and they usually require a laptop for programming, minus low-end Honeywell systems. Now for a historical example, we have the shunting type coded system. It is a historical way to differentiate pull station locations on conventional systems. It shares similarities with the Gamewell City fire alarm system, using a coded wheel to ring bells and horns in a specific pattern to indicate the location. It can be used to make a single zone system much more accurate. It uses a normally closed contact that opens when a device is active to ignore devices further away from the panel to prevent interfering with the current pattern. Unlike non-coded conventional systems, each pull station has its own pattern that it sends to the horns or bells to indicate alarm position. They are also very interesting to hobbyists. Now, on the downside, buildings are not hobbyists. These are no longer legal in modern fire alarm code. Only legacy systems are allowed to remain. The shunting ignores other device alarm status, and usually these systems do not use any automatic initiating devices, and when they do, these devices are usually non-coded. And another example of a historical system is the positive non-interfering coded system. It is a historical way to get multiplex systems before microcontroller technology matured. These were called passive multiplex systems versus your modern active multiplex system. These are very rare nowadays. Systems include the article I don't know how you pronounce it, and the Honeywell W247G. Unlike shunting coded system, these use electronic motors to drive the code wheels, allowing these devices to wait for one station to end its code cycle before continuing its coding cycle. Unlike shunting coded systems, devices further down the line or later on pulled wait for the active station to stop coding to start their own code cycle. A coded station can be connected to a conventional device to run like a transponder system. And also the abbreviation of the system is PENIS. Very funny, I know. Downside is these are no longer legal in modern fire alarm code. These are heavily complicated, hard to service existing systems, and they usually run at odd voltages. Now, back to modern type systems, we have the voice evacuation system. This can be either conventional, addressable, or multiplex system with a tone generator, microphone, and amplifiers to go to speakers throughout the buildings instead of bells or horns. They're commonly seen on high-rises, auditoriums, and are now required in most K-12 schools. They can also implement mass notification, allowing the fire alarm system to warn of other emergencies, such as tornado or lockdown. Compared to other systems, voice evacuation systems use speakers instead of bells or horns that speak in the local language to tell people the exact emergency, which can be fire or other mass notification type emergencies. They can be used for paging specific parts of a building to direct announcements, and are usually tied to music systems to automatically shut them off and play emergency messages through those speakers. However, these are much more expensive than horns or bells. They usually require an advanced fire alarm control unit if you want more fine-tuning instead of just play sound when alarm. And bad wiring can cause static noises to play through speakers. And finally, we have the network system, which is used for large complicated buildings that usually all tie together, such as a complex. You see these in universities, skyscrapers, office parks, and the like. They're usually only useful if every system in the area is by the same manufacturer, especially if you have a good contract with them. The type of networks you can see are Notifier Net for notifier systems, Simplex 4120 for a mix of legacy and modern simplex systems, or ESNet if using exclusively newer systems. Unlike multiplex, each panel on a network is a fully fledged system. Compared to other systems, these are very useful when you have a central safety building and can monitor each building's safety status. They can allow for mass notification systems to integrate site-wide alerts, and can allow all strobes in a network to synchronize if a building uses networks, like when you have a high-rise. The downside, you must use systems by one fire alarm company, such as All Simplex or All Notifier. And integrating another company's system usually entails that specific system lacks the advantages of the rest of the network, and if that system is currently active, it cannot communicate with the rest of the network.